Hello, my name is Krishna Turlaparthi. I'm a director of software engineering in the platform team. Today we're going to take a look at investigating ROXIE queries using the ROXIE logs. When it comes to deploying queries and data to HPCC systems on cloud, the usage and operation is designed to be similar to that on bare metal systems. Migrating or transitioning to cloud-based HPCC systems should be seamless. Once you have set up an HPCC system on the cloud, the next task is to get the data and the ECL queries to the cloud environment. Today, we are going to take a look at migrating ECL queries, migrating data using package files, investigating ROXIE queries using log files. As part of the investigation, we're going to take a look at factors that impact query performance, what to look for in the ROXIE logs, and new tools that are available for us. Before we get into the topic, let's take a step back and look at how do we access the HPCC cluster that we set up in the cloud. Let's take a look at how do I access my ECL watch page? How do I access the WSECL page to run my queries? And what is my DALI IP address? To get the information about the services, you can run kubectl get service command. This will give you information you need to access your ECL watch, WSECL pages. In addition to the other information, you want to pay close attention to the IP addresses and the port information for ECL queries, ECL watch, and my DALI information. Which I'm highlighting here for the ECL watch, the ECL queries, and the DALI information. To get the information about pods and their names, you can run kubectl get pods command. This will give you information about the pod names, status of the pods, and how long they have been running, and if there were any restarts. Once you have all this information, you can use the external IP address and the port information for ECL watch we got from running kubectl get service command to access the ECL watch page. If you want to access WSECL, you can use the external IP address and the port information of ECL queries. That will give you the WSECL page where you can access your queries once you have deployed them under ROXIE. Now let's take a look at migrating ECL queries to your cloud environment. Now, how do you get your queries to the cloud environment? There are two traditional ways of getting queries onto HPCC systems, either compiling queries from ECL code or copying existing queries from another cluster. This is still true for the cloud environment. Let's start with copying existing queries to the HPCC system in the cloud from either another cluster in cloud or from a bare metal system. To get your queries to the cloud environment, you can either copy individual queries or copy the entire query set. If you're copying existing queries from a bare metal or another cluster to your cloud environment, make sure you're running same or compatible versions of the HPCC platform on both the environment. Otherwise, you will have to recompile your queries on the cloud environment. To copy individual queries, use the command ECL queries copy and provide the source IP information, the port information, the query set name, the query name, and specify your target IP in the target cluster. To copy the entire query set, use the command ECL query copy set and provide the source IP, port, source cluster name, target cluster name, and the target IP information. If you want to compile queries from your code repository on your local or use a local ECL file, you can use a command line, the ECL IDE, or a third-party tool such as VS Code. You can use the command ECL publish by providing the target where you want the query to be published, the file name you want to use, and the name you want to provide for the query. Now, let's take a look at what happens when you actually compile and publish a query from a command line. Here, I'm using the ECL publish command. The server IP address is the IP address of the ECL watch we got from running the kube control get service command. I'm specifying the target cluster as ROXIE. I'm using cities by state search ECL file that is on my system to compile the query. I'm specifying no file because I do not want to copy any files because I'll be using a package file for this. And I want to call the query city by state search. When I run the ECL publish command, the code is compiled and it gives me warnings and error messages related to my code. If there is an error, the compile fails. In this instance, it is giving me a warning that I have not specified a limit or a chosen in my join condition. At this point, I can go back and change my code or continue with the publish code. Once the compile completes, it will create a work unit file and publish my query onto the cluster. Now, you can see on the ECL watch page, the query is published. So you see the query ID, the name I've specified, the work unit that was created. But right now it is in the suspended state because I said no files in my publish command and haven't deployed a package file yet. Now let's take a look at what happens when you copy individual queries from an existing cluster to your cloud environment. Here I'm using ECL queries copy command, and the source IP address I'm specifying as localhost, which have it on my system. I'm running a cluster on my local machine. You might want to replace this with the IP address of the system you want to copy the queries from. And the port is 8010. I'm using the cluster name as ROXIE demo, and my query set name is, so my query name is city population count. The target server IP address is the IP address of the ECL watch, and the cluster name is ROXIE. When you run this command, the city population count query is copied from source cluster to the cloud environment, which is your target cluster. When you copy a query from one cluster to another, there is no compilation involved. The work unit along with the dependency files are copied from source to the destination. Now let's take a look at what happens when you copy a query set from an existing environment to your cloud environment. Here I'm using the ECL copies query set command. Again, the source IP address is localhost in this instance. But again, you might want to replace it with the ECL watch IP address of your source cluster. The source port is 8010. The target server IP address is the IP address of the ECL watch, and the cluster name is ROXIE. I'm specifying the cluster name here, but no specific queries. I want to copy all the queries from my source cluster to the target cluster. So I don't have to specify the query name, just the cluster name is sufficient. When you run the command, it will copy all the queries from the source cluster to the target cluster. In this instance, I have two queries that are sitting on my source cluster. So it is copied both the queries from my source to the target cluster in this instance. Let's take a look at migrating data from one cluster to another. And using a package file to get data onto cloud. Once you have your queries on the cloud, you need to get your data to run the queries. You can do this using a package file. You can build your data in the cloud environment or copy your existing data. To copy existing data to the cloud environment from an existing environment, you have two options. You can copy your existing package file or add a new package file. If you want to copy an existing package file from the bare metal or another cluster, use ECL package map copy command. Specify the source IP, the port information, and the package map ID, along with your target cluster name, your target IP address, and the DALI IP address. The DALI IP address in this instance is the DALI IP of the source, not the target. Once you run this package map, this is where your target ROXIE will get the file information. If you downloaded the package file to your local machine or want to use a new package map file you have created, then you can do this by using the command ECL package map add. You provide the package file name, your target cluster name, target cluster IP address, and your DALI IP. Again, this is the DALI IP address of where the files are. So if you're building your own files on your Thor, your DALI IP address will be where the ROXIE can get the file information. Once you have deployed your package files, you can see the logs on the pod and notice the data copy starting. If you're updating a package file, assuming you're using persistent storage, you will notice the DALI lookups to verify the keys in your package file are existing on the current ROXIE. And the files, and you'll see the DALI copying new files that are required based on your package file. Once the data and the queries are on the cluster, you will be able to run your queries and update the data in the same manner as it was done on the bare metal system. Now, let's take a look at what happens when you add a package file. Here, I'm adding a package file that I created that is on my local system. Here, I'm using the ECL package map add command. The target server IP address is the IP address of the ECL watch. The DALI IP address is the DALI IP address. The DALI IP is the IP address of the source DALI where the file information is available. I'm using HPCC test.pkg file. I'm also specifying -a option. What this does is it activates the package file once it is added to the cluster. When you run the command, it will create and add a package file to the target cluster. Once the package is added, the data will be copied to the target cluster. Here, because of the -a option, you can see that the package is activated. Now, let's take a look at a demo of compiling and publishing query and adding a package file to the cluster. Here, I'm going to run kube control get service to get the IP addresses for my ECL watch, my ECL services, and the DALI information. As I mentioned earlier, you can use the IP address of the ECL watch and the port information to access the ECL watch page, and the ECL queries IP address and port to access the WSECL page. And that is the IP address for the DALI. Now I'll run the ECL publish command and specify the target ROXIE, the server IP address, which we got from kube control get service command. And here I'm going to specify no files because I'm going to use the package file. Now on the ECL watch page, there are no queries that are currently present. When I run the command, it compiles the query, it starts to compile the query, and once the compilation is completed, it will deploy the query for me. Now, once the query is deployed, you can go to the ECL watch page and see the query that's currently present. I still need to add the package file because I don't have anything on the cluster right now. In order to do that, I'm going to run the command ECL package map add and specify my package file. Once the package file is deployed, you can see the package file is added and it is active. And I have a simple package map where I'm specifying the query and the data package IDs I need to use for that particular query. Once my package map and the queries are added to the cluster, I can go to the WSECL page, go to the ROXIE cluster and look at my queries. And here I'll be able to run the queries because I've added a query, I have the data, which it is getting from the package file. As you can see, now you can execute the queries. In order to look at the logs, you can use kube control, get pods, and get the pod information where you want to look at the logs. So here you have the pods for the ECL watch, for the ROXIE agents. You want to take a look at the logs for the ROXIE agents. You run kube control logs in the pod name. In this instance, I want to look at the logs for the ROXIE pod. That will give me the log information for the particular ROXIE pod. Now, if I want to tail the logs or follow the logs, I use the same kube control logs command, but specify -f in order to follow the logs or tail the logs while I'm running the query to see what is going on. In this instance, I'm using the IP address of my target cluster for the DALI IP because I built the data on the cluster and the data is available on my cluster and the DALI already has that information. Typically, you would want to use the DALI IP address for the cluster where it has the file information. Now, let's take a deep dive into investigating ROXIE queries using log files. Some of the topics we are going to look into are related to query performance, load information, log messages, query stats, and the WHO tool. When it comes to query performance, the basic factors that determine the performance is if the cluster is cold or warm. When you run a query for the first time on a cluster that is set up, the cluster is in a cold state. That means all the data is read from disk. This means the performance of the query is relatively slower. In this instance, when we run the query in the cold state, the query takes 1400 milliseconds to run. After you run the query a few times, you're warming up the cluster. What that means is the data remains in memory as long as there is room for the subsequent calls to store the data in the memory. So the next time you run the query, the data is read from the memory and not from the disk, thereby improving the performance of the query. In this instance, when we run the exact same query again, and the cluster is in a warm state, it takes 234 milliseconds compared to the 1400 milliseconds it took when we ran the query while the cluster was in a cold state. Now, how does load impact the query performance? For a simple or low resource intensive queries, let's assume you warmed up the cluster and you're running a simple query on an idle cluster. From the logs, you can see the performance is pretty good, which is 204 milliseconds. Now, if you run the same query with 80 other miscellaneous queries, which are similar to the one you previously ran, you can see the performance is similar to the previous one, which is now it is about 208 milliseconds as compared to 204 milliseconds. This is because you're not putting too much load on the cluster and your queries are not very process intensive. They are simple queries. As long as you have enough threads and resources, your query performance will be consistent. Now, let's take a look at how does load impact the query performance for resource-intensive queries. When you run a single wildcard search on an idle cluster, let's say your query completes in 2500 milliseconds. Now, if you run the same wildcard query with 80 other miscellaneous queries, you can see the performance deteriorates to about 4400 milliseconds. The 80 miscellaneous queries could be a combination of simple queries, a little complex queries, could be anything, but the performance still deteriorates a little bit. Now let's take it a step further. And if you run the same wildcard query with 50 other wildcard queries, you can see the performance deteriorates drastically to 29,000 milliseconds from 2,500 milliseconds when the cluster was idle and no other queries were running. This is because all the 51 queries are resource intensive, causing a contention for resources. One thing we have to remember is that the resources a query needs are not equal. Some are simple queries which will need low resources. Some are resource intensive queries. If you're planning on running resource intensive queries on the cluster, we have to find ways to improve performance. Having more CPUs on each ROXIE node would help the situation, in addition to looking into improving or optimizing the ECL code. Let's take a look at the messages you see in the log file. Some are informational messages, and some of them point to a potential problem, and we'll give you information on how to optimize the ECL code to improve the performance. When you see a message like no message collator in the log file, this is not an error message, but instead it is an informational message. All this means is that ROXIE already received the information it needs from an agent, and it is no longer looking or waiting for information from other agents. Hence, no message collator. When you see additional data message in the log files, this is because the maximum packet size is a 64 KB. All this message means is there is more than 64 KB data that the agent needs to send, and it is sending 64 KB data and letting ROXIE know that there is more data to come. Again, this is an informational log message and does not indicate any issue with the cluster. Now, let's take a look at some of the key aspects of log messages for a complete query. This is how a single transaction query looks like in a log message. Some of the important aspects of this log message are agent reply. This is the total data that is coming back from all agents. This is a clue which could indicate too much of data might be coming back from the agents. You might want to look at the ECL code or the data file to see if you really need all the information coming back from that agent. Is there a way for you to reduce the amount of data coming back from the agents, which might speed up the process? The next one is num-index while seeks. This might indicate a process-intensive operation. You want to avoid while seeks as much as you can. The next one is the time agent waits. This is the time that the ROXIE is waiting for an agent reply to come back. These are some of the aspects of the log message which might help you improve and debug the query performance. The longer it waits for a reply from an agent, or the more number of while seeks, or the more data it has to wait from the agent, in addition to the other aspects of the log message, will give you an indication why the query might be taking as long as it is, and ways for you to improve the performance of the query. Let's take a look at some of the messages in the log file which might point a potential problem with the cluster or network. When you see a message, get next result timeout, this means that ROXIE did not get a reply from the agent. This could indicate the agent is busy or doing too much work to reply. The next one is the input stalled message. This is similar to the get next result. Basically, the ROXIE did not get a response from the agent and will retry again in 10 seconds. This indicates that once the total performance of the query is going to deteriorate because it has got to wait for 10 seconds before it retries. Too many active queries. This could indicate that ROXIE is overloaded. There are not enough threads to process the request. Timeout waiting. This indicates there was no response from the agent after 4 retries. This could be an issue with the network, or could be an issue with the nodes, or something going on with the agents. Now, failed to get response. This is pretty straightforward. This is basically the ROXIE saying, I did not get a response from the agent, which could be due to multiple reasons, which we have mentioned earlier. We should take a closer look at any of the above messages in the log file, because they could point to a problem with the agent, load on the ROXIE, or a network issue, or issues with the nodes, resulting in the performance and availability of the cluster. Now, how to determine what size of a cluster you need to set up? There is no fixed formula to determine this. It will depend on multiple factors, like what type of queries will you be running on the cluster? What are your TPS requirements, which are transactions per second? What are your performance requirements? Do you have any SLAs where you need the query to respond in particular fixed amount of time? These factors will determine how many servers you will need, how many agent threads you will need, how many CPUs do you need on each ROXIE, how much memory do you need on each node. So these are just few of the factors that you need to consider while determining the resources and the size of the cluster you're going to set up to run your queries. Now, let's take a look at the query stats. To get query stats, you can use test socket utility for published queries. When using test socket, you get activity metrics, query aggregates, query stats, in addition to the other metrics. So you can use your test socket utility. Recently, a new option called stats to work unit was added to get query stats. The way to use this is you can add stats to work unit equal to 1 option to the XML query input. Run the query, and then look at the work unit you have created after running the query. Now, if your query makes a call to the library, you can get the query stats for this by specifying the library name as the query ID and using the query stats option. The stats you get from the calls are cumulative for that particular query. So the more number of times the query runs, all the metrics are added and you get a cumulative values. If you're trying to debug or collect stats for a query, then you can reset the query stats and then run the query once before collecting the stats. That will give you the stats for a single query run. You can do this by using the test socket with reset query stats option. You want to be careful while collecting and resetting the stats for a query. Make sure the query is not being called on the cluster while you're running this. In other words, you or no one else is running the query while you're resetting or collecting the stats. To collect the query stats, use test socket with query stats and specify your query name. This is how a sample query stats.xml output file looks like. In this, we have information about one node. Typically, you will see multiple entries for this, one entry for each node in the full XML stats file. Now, pay close attention to the time local execute in every node of the XML file. This will give you information about the query performance. Now that we have our query stats, let's take a look at the Woo tool, which is a new tool that will be available soon. You can currently use this as a standalone command line option. This will be added to the ECL watch as well. You can run the Woo tool on the stats file that you created in the previous slide, which if you go back, this is the stats file you have created. You can run the Woo tool on this by running the Woo tool hotspot command on the stats file and specifying the DALI server. This will give you a tabular output. In this output, the name is the activity name. R is included if this activity is the root of the dependency. The parent is the parent activity ID. The total percent is the percentage of time spent executing this activity. Start percent is the percentage of time spent in the on start phase, basically processing dependencies. Maestra percentage is the percentage of time spent excluding the dependencies. And run percentage is the percentage time spent executing this activity, excluding time taken by inputs. Now, you have additional commands you can use to identify dependencies and common paths between activities, and how long an activity has been waiting with this tool. This will help you debug issues with the query performance and help you identify the activities that are taking too long and are impacting other activities, which will ultimately result in negatively impacting the performance. In order to identify the dependencies between two activities, you can use the Woo tool dependent file and specify the activities. In order to identify why an activity is waiting, you can use the same Woo tool dependent file and specify the activity and the start time of that. In order to identify what activities were active in a range of time, you can again use the Woo tool dependent file and specify the start and the end times, which is basically your range of time, and to identify the activities. Now, in conclusion, when you're trying to identify issues with query performance, look at the logs for complete stats. The logs will give you a lot of information, as we have seen previously. They'll give you informational messages, which will tell you that something is going on or you're pulling too much data, but not necessarily an issue. They'll give you information in the log files, which could be a problem with the ROXIE, could be a problem with the query, could be a problem with the network or some of the nodes, like the messages we have seen previously. Then look at the log files and pull the complete stats for the query. Then run the Woo tool hotspot to identify the hotspot in the query while it is running. For library calls, get the timings for the library to see if that is impacting your query performance. Look at the SOAP calls to see if they're starting late. Is your query waiting for the SOAP call to complete, or is it waiting for something to happen before the SOAP call is executed, which might impact your query performance? Look at the activities to see if they are waiting for other activities to complete before starting, or can you perform these activities in parallel? If not, if one activity is dependent on another activity, how do you speed up the first one so that you can improve the performance of the query, overall query? The stats and tools give you a lot of useful information, which will assist you in identifying activities that might be impacting query performance. Let me know if you have any questions. That concludes my presentation. Thank you for your time.